All right, we're going to be looking at functions, and there's different ways we can look at a function, and we're going to be asked if a relation represents a function. Now, if you're given a graph, there's a real easy way to tell if it's a function, and this is what we call the vertical line test. If I take a vertical line, if a graph is a function like this one here in the middle, a vertical line, if I take it all the way across, it will only cross that line in one place. So if you look at this graph in the middle, it passes the vertical line test because it only crosses in one place all the way across. Now if you look at the graph on the left, it has some curve to it, but as I go from left to right or right to left, it only crosses at one place all the way across. There's only one place that it's going to cross. And if you look at this, what I mean by that is, looking at this vertical line right here, it only crosses the graph in one place. Now if I were to go over to this other graph over here on the right, it would not be a function, because if you look, the circle over there, it actually crosses the graph, it actually crosses that circle in two different places. So this one on the right would not be a function because it does not pass the vertical line test. It crosses that graph at more than one spot. Now you look at this graph here, this one's one of those where it crosses at more than one place. So this is what we would say is not a function. Okay, it does not pass the vertical line test. There are two places on this graph where a vertical line would cross, so that would prevent this from being a function. So that's a real easy way to tell if you have a graph. It doesn't matter how much curve the graph has to it. Now if we look back up here, there was a lot of curve to this graph on the left. It does have a lot of curve. Now it does not matter that it has a lot of curve. What matters is, does it pass the vertical line test? Because if I'm looking at a graph, let's say I had a graph that looked like this and just has a whole bunch of curves, that's fine as long as I can take a vertical line right here and I can move it across. It only crosses that line. Even though there's a bunch of curves, that's not what makes it a function or not. It's, does it pass that vertical line test? There's only one place, no matter where I put it as I go left to right, that this vertical line crosses that graph. Okay, and we're also going to see the functions listed as diagrams, like right here, and we can't use the vertical line test on these. This isn't a graph, but what I want to look for is, I want to make sure, I want to look at the left over here, every single input that I'm dealing with. I just want to make sure, if I'm going to be able to tell if this is a function, every input can have only one output. So if I'm looking at, let's say for example, -1. -1 is an input. It can only go to one other number, and that is it. -1 only goes to 5. 0, if you look at 0, it only goes to 3. 1, down here, +1, that's the only time it appears, goes to +5. Each one of these inputs only has one line coming out of it, and that's what makes this relation a function. Every input has only one output. Like this -1 only gave me one number. It didn't give me some other number. That would disqualify it from still being a function. Now if you look at the diagram on the right though, this is not a function. Now the first input, it only has one output, but if you look at the number 2 here as an input, it actually goes to two separate places, right? If your input has more than one output, it is no longer a function. So the graph on the diagram on the left, it would be a function. It actually works. This one checks off. But if you look at this one on the right, it is not a function because every input does not have just one output. So this is not a function. It does not work, okay, because of this point right here. Now every other input in that set has only one output, but if even one of them has more than one output, it is no longer going to meet the definition of a function. Now an input can actually have the same output, and this is where it gets tricky. People see this and think this is not a function because, you know, 1 goes to the same number, 2 goes to the same number. But an input, as long as this input has only one output, it still checks out. So 1, it only has one output. 2, it only has one output. 3, it only has one output, and so does 4. They might all share the same output, but that's okay. this would still be a function. This still checks off because for every input, there's only one output. Okay, so as long as every input only gives me one output, we're okay. So every input here gives me only one output, and that's what I'm looking for. I want to make sure it doesn't matter if they all share the same output, as long as there's only one line coming from each one of these inputs in the diagram, we're okay. What I don't want to see is a set of numbers over here where this one has two possible choices. Okay, I don't want to see anything where, and it doesn't matter, these can all share the same one, but for it to remain a function, I cannot have something where this number over here on the left, this input, gives me more than one output. If we're given a set of ordered pairs and we're asked to figure out if it's a function, just make sure that every input, in other words, we usually call these x's and y's, but every input can only have one output. So 5 only gives me a 4, 4 only gives me a 3, 3 only gives me a 2, and 2 only gives me a 1. So I have all these inputs, 5, 4, 3, 2, and 1, and each one of them only has one output. So that's a function. But if you look down here in the bottom, positive 1 gives me 1, and it also gives me 2. So this one no longer qualifies as a function because the input 1 gives me more than one output, and it gives me a 3 over here, it gives me a 4 over here. So the input here, the x, it's just another word for input, an x value, is giving me more than one y value. So it would not be a function because for each input I can only have one output, and this one has 4 different outputs for the exact same input. So if you're looking at a set of ordered pairs, you're checking to make sure that every x has only one y value. Okay, so in this unit we're going to be looking at some vocabulary, and basically there's a bunch of the same words used to describe bunch of different words used to describe the exact same thing, and I want to kind of help you out here because we're going to be talking about an x and a y. Okay, and just like in the alphabet, x, if it's an ordered pair, x comes before y. Well, if we're talking about domain and range, that also goes in alphabetical order. Domain comes before range in the alphabet. D comes before R, x comes before y. Input is an x value, and output is a y value. These are just different words for the exact same thing, and if you kind of know what's what, it's going to help you out in this unit, because vocabulary, it always seems to kind of mess us up here. They'll ask what's the domain, and you'll see a set of numbers, and if you don't know, if I gave you these two numbers and I said what's the domain, if you don't know that domain's an x, you're going to miss that question. It's a really simple question as long as we know kind of what's what. X is domain, it's an input. Y values, range, they're just outputs, different words for the exact same thing. Now, and if you notice, all three of these go in alphabetical order. X in the alphabet comes before Y, domain, D, comes before R, I comes before O in the alphabet. You can all, and I used to use this table to kind of help me remember which one goes where. So if I gave you a set of numbers and I was asking you to find the domain and the range in a set of numbers, you're just make sure you know what is being talked about. What is being asked? What are you being asked to find? So here, and this is a question that you'll see in the homework, where they're going to ask you which set of ordered pairs has a domain of, and they'll give you a list of values like 1, 2, 3, 4. Well, a domain, if you know that a domain is an x value, okay, x always comes before y. I'm looking at these ordered pairs and I'm specifically looking at the x's because it's asking for a domain. I'm looking at only the x values. All right, so I would go and look at these ordered pairs and I would see which one has a domain of 1, 2, 3, 4. Well, if you go through the first two sets, it's obvious this first one is the domains are 2, 8, 4, and 6. So it's not this one. But down here, 1, 2, 3, and 4. Those are the domain values. Those are the x's, and that's what I'm being asked to find. So just make sure we have those in our head kind of squared away, which ones are which.